So this is a chicken egg, and I bring it out here because we're going to talk about sexual reproduction and how you can inherit diseases that are related to the mitochondria. So I'm going to start with the chicken egg because in the process of reproduction, at least with animals, the female provides an egg, which is pretty big, and the male provides a sperm, which is pretty small. Now, if you can hold the chicken egg, in this diagram here, this blue circle represents the egg of the female, and the smaller circle represents the shape of the sperm, okay? The pole represents the nucleus of the egg, which is where the female's DNA would be stored, all right? Now the sperm has DNA too, and that's right here, okay? Now the female has cytoplasm, which is all this area, and that's an important source of nutrients for the developing baby. And these are our friends, the mitochondria. These are what you know as the powerhouse of the cell. They convert sugar into ATP. So there'd be a lot of mitochondria in the cytoplasm, right, of the female's egg. Now the process of fertilization happens when the sperm motors its way up to find the egg. It has to swim a great distance. So there's this long whip-like structure called the flagellum, okay? Now the flagellum is like an outboard motor, and it needs a source of ATP. And the mitochondria is really here at the base of the flagellum, and it gives it the ATP it needs to spin. But I'm just going to put it out here to make a point, okay? So it's a race. The first sperm to find the egg touches the egg and is allowed to send its DNA into the cytoplasm of the egg. Now, the process of fertilization has been completed, where the DNA from the female combines with the DNA of the male, and that'll make the embryo and eventually the baby. So that's how it goes. Notice that none of the mitochondria from the father went into the developing fertilized egg. Now, if the father had some kind of dreadful mutation in the DNA of his mitochondria because of those harsh chemical reactions, it wouldn't matter at all, because the father's mitochondria does not go into the egg. The only thing that goes into the egg is this DNA. Now, if the mother, on the other hand, had some kind of mitochondrial disease, and she might not even know about it if she's young, if she's only like 20, 30 years old, going to have a baby for the first time, she might not know she had inherited a disease. It might only show up until she's 40 or 50. And of course, if it's a mitochondrial disease, she would be running out of ATP, and there's lots of different types of those diseases. So if the child ends up with an inherited disease, it can only come from the mother. You cannot inherit a mitochondrial disease from your father, because the father only contributes, what does the father contribute? DNA and nothing else.